Hello, Algebra 2 Accelerated. It is week 7 of Algebra 2 Accelerated Distance Learning Style. Pretty exciting, week 7. Got about 3 weeks left, so we've got some cool stuff in store for you math-wise. And yeah, let's get started. Today we're going to be doing some graphing of sine functions. And there's lots of different ways to approach this. As you can see, the goal is just graphing sine functions. So the way that I'm going to teach it is that we are going to graph what are called transformed sine function, which transformed just means changed. So we're going to look at where does a sine function come from? Like where does the original function come from? Like a parent function, if you remember that from quadratics. We're going to look at the parent function and figure it out. And then we're going to figure out how do different numbers change the way the sine function looks. So before I even get you started on doing all the actual math part of this, I want you to get a chance to play around with what the function looks like. That way you have a little bit of knowledge what's going to be coming up. So go ahead and go to this website that I have here, this bit.ly 3fxwmt8. It's going to take you to a browser version of Desmos. You're going to play with the sliders a little bit. I'll show you the sliders are K, H, A, and B, so they're all there for you. And then when you get to the website, it should look like this. Don't worry about the table. I had to be kind of fancy with the table to make it work. So just scroll down here on the side and look at what each slider does. You might be able to see the graph has an A, sine B, x minus h plus k. So each one of those letters is represented in one of the sliders. And so, for example, if I move the k slider up, you notice that the entire picture of the sine graph goes up. And if I move the slider down, the entire picture of the sine graph goes down. So then you would go over to your notes and you would explain in your notes, in your own words, what you just saw. So maybe you like to say the middle line went up and the middle line went down. When k is positive, it shifted the whole thing up. When k is negative, it shifted the whole thing down. You decide. And I'd like you to do that for all of the different sliders. So I'm going to pause for a second, and then when I come back, hope we can discuss some of the things you saw happening to the sine graph. All right, let's go over some of the language that you might have used, and we can switch our language around. This is just us warming up our brains on the topic we're going to be talking about. Move my thing here so I'm a little more focused. So the k value we looked at together, it shifts the whole function up and down. Let's look at the h value now. What does the h value do? Let's scroll down here. Here's h, and we can see that if we move h, those blue dots, which we'll talk about what they mean, but notice how they move to the left and the right. They go to the left when h is negative, and they go to the right when h is positive. All right, so you could write something about that. For b value, well, let's set everything back to the beginning here. 0, 1. And we'll talk about what these values mean in a little bit, but I just wanted you to get a chance to see, like, overall, what does a sine graph look like? And I want you to see overall what these little things change about the sine function. All right, so then b value, if I were to change the b value, you would, that's the h value again. Oops. Okay, so if I were to change the b value, and it makes a big difference, it squishes those points closer together, and it makes it go up and down faster, right? And then if we go to the other way, we see that it's making the numbers go or the dots go further and further apart, and it makes the humps wider, almost like slower waves, right? If you're thinking about sound waves, this would be a lower pitch sound. If you had a larger B value, you would get a higher pitched sound. All right, and so let's talk about, where do these waves come from? Why is this what a sine graph looks like? And kind of start there. Okay, so we are going to do something super fun. I know you guys have had so much fun memorizing the unit circle. I've gotten some really great videos from you guys. It's been nice. Some people have figured out that they did it with a screen share, but which is fine. I just like hearing your voices when you're doing the unit circle quiz. It's pretty cool. And I like getting to see you guys work on them, for those of you who recorded yourself, like sitting at a desk or a table or whatever it might be. So keep it up. Keep those coming. Remember, late work is accepted until the end of the quarter. So don't worry. If you're a little bit behind, you have time to catch up. Don't give up. All right. So what I'd like you to do is pause and test yourself. Can you fill out this unit circle? So I'm going to do the same thing. I'm going to pause so that I can do the unit circle myself. I love doing it. It's like in elementary school when you used to have like multiplication races or addition races or whatever. So I really, really like it. So I'm going to pause. I want you guys to pause also. Go ahead and fill out the unit circle the best you can, and then come back and check your answer. We're only going to be looking at the radian values today, so you don't have to put the degree values in if you do not want to, but you can if you want to, so if it helps you. Sometimes people use the degree values to help them remember the radian values. So it's up to you how you want to do it. You only need the radians and you need your points. Okay, so here I go. I'm going to pause. Just for fun, see if you guys can beat me. I bet you for sure can beat me with the unit circle. Okay, you guys ready to see? All right, I got a pretty good score, or a good time, I mean. I got 2 minutes and 50 seconds. So, if you minused a couple seconds for me having to like get the timer started and do everything, maybe closer to 2 minutes, 45 seconds. Pretty good. I didn't do the degrees though, so maybe that would have added another minute or so. All right, so here's our unit circle because we don't need the degrees. And what we're going to do is we're going to look at the unit circle, but we're just going to look at the sine value of the unit circle. So remember when we were finding the different values, we were figuring out where the different X and Y coordinates in the unit circle come from. We looked at these triangles, right? We looked at these bow tie created triangles, and we saw that the Y value here was found by doing the sine of this angle, which is the opposite over the hypotenuse, and the unit circle always has a hypotenuse of 1. And so the big idea is that the Y coordinate is just sine of whatever the angle is. So let's get rid of all these extra confusing lines on here. But let's, I'm just going to keep it simple. This week, we're going to look at sine. Next week, we're going to look at cosine. So what I'm going to do is I'm going to erase all the cosines. All the cosines are the X values. So get rid of those. We're just going to look at the sines, and I want to get rid of everything except for the sines here. Oh, look, I forgot a 0 in that last one. Okay. Only looking at the sines, only looking at the Y values now. And so what we're going to do is we're going to take this visual representation of the unit circle, and we are going to put it into a table. Remember, multiple representations. We're always talking about, is there a graph? Is there language? Is there context? Is there a table? Is there an equation? And we want to make sure we understand as many different representations as possible, and that we use as many different representations to help us understand the big ideas behind what we're trying to learn. So let's start. We're going to work our way around the unit circle. We're going to go around in this direction, and it's going to take us from top to bottom in the table. So again, we're going to be filling out step by step a table. Might take a little while, so you can follow along with me, or you can choose to pause, skip ahead. It's up to you. These videos do get a little long, but that's just because I'm trying to give you extra. And if you don't need that extra, then you don't have to watch it. Okay, so let's start at the beginning. We're starting at 0 for our radians. And I'm just going to put in my sine value that goes with that, which is this y value of that point, right? It's 0. So the sine value there. Now, if you're not sure and you want to check your answer, you can use your calculator. And you just make sure you're in radians. And so you would go to the second page, make sure you're in radians. There I go. And I would do sine of 0, and hopefully I get 0, which I did. Okay, go away with this advertisements. So you could do that all the way through. Your calculator is going to give you decimals, so you just have to double check that the decimal is the same as if you put in the like √2/2 and you get the same decimal as your output. Let's do it. Let's get after it. So the second radian that we're going to put in is pi/6. And that has an exact sine value of 1/2. Again, I'll do it one more time just to make sure we understand. I'm in degree mode, or I'm in radian mode, so I just have to go sine and then put in pi/6. And I get 0.5, which is the same as 1/2. So I know I'm on the right track. I got it correct. Okay, so let's keep going here. We got pi/4, we have pi/3, and we have pi/2. I will tell you what those highlighted cells mean, what those highlighted rows mean. √2/2, √3/2, and this one is sine is y, so that would be a 1. All right, I'm just going to keep working my way all the way around the unit circle. Like I said, it's going to take me a little while. You can skip ahead if you want, or you can come along with me on this journey. So I'm going to do next is 2pi/3, 2pi/3, and then I have 3pi/4, and then next I have 5pi/6, and then finally pi, right? Okay, so now let's pick up those sine values. I can see that my sine values are going to be √3/2, √2/2, 1/2, and then 0. So let's go and fill out our table here. I have √3/2, I have √2/2, and I have 1/2, and then 0. Notice how it's in the opposite order, like this one goes up to 1 and this one comes back down from 1, but they're in the same, it's like going up to 1 and coming down back to 0 because we're in the y's, right? So the y's are going up and down. The x's go left to right. We'll deal with that tomorrow. All right, let's keep working our way around the unit circle. We're going to start getting some negatives now, which is kind of fun. So this right here, we do 7pi/6, 5pi/4, 4pi/3, and then 3pi/2. So let's get those in the table. Coming back over here, we have 7pi/6, we have 5pi/4, and we have nope, that's not right. We have 4pi/3. Tons of different cool patterns that come up in the unit circle. So I hope you guys were able to find some that help you memorize it. All right, so now this would be, let's look back over here. Our sine values are -1/2, -√2/2, -√3/2, and -1. So -1/2, -√2/2, always in the middle, right? √2/2 is always in the middle. And then -√3/2 because it's the largest out of those three. And then finally we would have 3pi/2, which is going to be at -1. We're at the bottom of the circle. And the unit circle has a radius of 1. So we're going down 1 in the y direction. So that's why our sine value is -1. Okay, let's finish off the unit circle here. We have 5pi/3, 7pi/4, 11pi/6. Okay, let's do it. We have 5pi/3, 7 pi over 4. I always get kind of nervous when I'm doing this because I'm like, oh my God, I'm a math teacher. I'm supposed to be perfect at this. This should be no sweat. I shouldn't even be thinking. But then I get nervous and anxious that I'm going to make a mistake. So I feel, yeah, this is not easy, and it makes you anxious when you're being timed or you have to do it on camera. All right, so then our sine values are going to be negative root 3 over 2, negative root 2 over 2, negative 1/2, and then back to 0. So we have negative root 3 over 2, negative root 2 over 2, negative 1/2, and then we are back at 0 at the end. Okay, so we are going to show where we get that cool wavy sine function using the circle. I mean, it's kind of the shape of a circle almost, where you're going up and then you're coming back down. You go negative and then you come back around. So again, starting at 0 and then going all the way down to, or going up to 1 and then back down to 0 and then down to negative 1 and then back up to 0. So let's apply this to our sine graph. What I want to make sure that we understand is that we don't have to put every single one of these points on every graph that we do. That's why I highlighted these key points. That's what I call them. There are 5 key points in every sine graph that you need to show in order to get full credit. So this first one is the beginning of the circle. That's right there. The second key point is the top of the circle. That's right there. Oh, that should have a 1 there. This third key point is when you're halfway around. And then this key point is when you're at the bottom. And then the final key point is when we get back to the beginning. And we could keep going around the circle over and over. That's why on the Desmos graph, it kept showing the waves more and more and more and more. Because you can keep going around the circle and getting the same values. But we're just looking at one cycle around the circle for the most part. Let's take a look. We know that the key points, I'm going to mark the key points, just like we did in our exploration of where do these values come from with the rope. That's why I have the rope here again to kind of hopefully trigger your memory about how we've approached this in the past. Remember, halfway in between is pi. Don't worry about making it perfect. That would be this key point right here. And then between that would be pi over 2. And then between that would be pi over, 3 pi over 2. I don't know what my brain was thinking there. Okay, this is going to be 3 pi over 2 there. All right, and we're just going to put those key points on, and I'm just going to highlight just to make it a little more obvious what I'm doing. The green key points are going to fall into that highlighted green area. And I'm going to use this blue again because it's blue is sine right now. I think that's the way I did it last time. I hope so. So at 0, we see our key point is also 0. And so we would put a point on the x-axis, which is 0. Then at pi over 2, we see that the output, right, the sine value is 1. So at pi over 2 as an input into the sine function, your output is going to be at positive 1. Now, it's nice to make a little line here just so we can see. We're going to see some symmetry, and it's going to go all the way up to 1, and then it's going to go down to negative 1, but we'll talk through it. Okay, so the next point you see here is pi at 0. So the sine value of pi is 0, so we put another point there. All right, keep going. We have 3 pi over 2 has a sine value of negative 1, and that's because we're down here at the bottom of the circle, right, where we're in negative y territory. So we would put a point down here at negative 1. And then finally, our final point, 2 pi, we're back where we started. We start back at the 0 line, the x-axis. And in this case, it's actually the theta axis because our x is actually our input, right? And our input is going to be our radians. So we'll call it a theta as for our input. All right, so now I could put all these other, and I've made so many marks here, I hope it's not too confusing, but we could go in and input all these other points into the graph, right? We could say, okay, let's make all these other 3 points in between the key points. And it would show you the shape that we just saw in the Desmos exploration where it's a wave. What I want you to do is just kind of memorize the shape of a sine function and get some practice muscle memory of just drawing the cycles, drawing the waves. So here's the best way to do it, in my opinion, is just to go up, go back down, and go back up. And notice how it's not perfect. That's okay. You don't have to make it perfect. I'm not grading you on whether or not like a little bit of the line falls out. So let's see it one more time, just so we can have the experience of seeing what it looks like to draw the sine function. You go up and then down and then back up. Notice the symmetry. That's going to be the most important part. This chunk here is the same as this, right? That length is the same because it's a quarter of the way around the circle and then halfway around the circle and then 3/4 of the way around the circle and then another quarter of the way around the circle. So, yeah, we're going to focus on just sine today. And of course, it gets more complicated than this. So watch out. These 5 key points are going to be the most important thing that you're able to place, and you're going to be using symmetry, and it gets much more complicated than this. So if you want to pause and practice making a sine graph a few times, I would definitely recommend that. So erase all of this that I just did. Right? Erase all of that in your notes and try to do your best to start from here and be like, okay, here's my pi. Here's my pi over 2. Here's my 3 pi over 2. I know it goes 0, 1, 0, -1, 0, and then draw as best you can. So if you can get those muscles working, your fingers working as best as possible, it'd be worth your time to take a little practice to do that. Otherwise, I'm going to go on, and we got some vocab, and we also have some tricky stuff coming up. So this is a good time. You want to make sure you're focused. You want to make sure you're ready. You want to make sure your brain is on. You want to make sure you can listen. So if that means you need to pause the video and take a break or go somewhere quiet or turn off your TV or turn off your music or whatever it is, please take a second to do that because this is going to be a little bit challenging. All right, so let's take a look at what we're learning about here. I'm going to get rid of this calculator. The sine function general form, and that is this fancy thing that I color-coded for us today. The general form of a sine function has an input of an angle, just like in your calculator you would put sine of 60 or sine of 3 pi over 4. Inputting an angle we call theta, and it has an output of the y value of the coordinate, exactly what we were just doing, where you're looking at the y coordinate of the unit circle to get the sine value in an exact form. There are 4 ways to change the sine function so that it looks different than the one we just drew. And the ways that this change is actually very, very similar to what we've seen before with quadratics. So hopefully you have a little bit of a remembrance of changing the vertex form of a quadratic. Let's start at the beginning. K is the vertical shift. You always want to look at K first. It makes the graph go up and down, just like we saw in our exploration. You want to draw a line at y equals k, or mark the graph, I'll show you what I'm talking about, to indicate where is the center of our graph. Okay, then 2, you look at the amplitude. Now, I'm not going to be testing you on, well, I will be going over like which part is which of the different of the graph. So it's a good idea to make sure that you know this vocab term because it's going to come up in the formatives. So is the distance between the center of the graph and the maximum or minimum. So let's take a look back up here. If we are looking at this graph we just drew of the parent function, right? This is the parent function of sine. That distance is whatever this distance is here and here. They will be the same because of the symmetry of the unit circle. And so this is 1 and this is -1. So the distance is 1. And so we would say the amplitude of this graph is 1. And we can change that. Whatever value we make A, that's how high up it goes and that's how far down it goes. And I'll show you how to deal with that. So that's why I say the neutral value, which means the parent function, has a value of 1. And remember that if you put a 1 in front of the sign, multiplying by 1 doesn't change anything. So a lot of the time, it just won't have an A value if you don't need to, if you're just going to have an amplitude of 1. Oh yeah, and then same idea here with the K value. The neutral value is 0. And so that would mean you could put +0 there to indicate that the K value is 0. But in general, since mathematicians are so lazy, they just don't write anything at all. So we'll see a little bit of this next part. It says if the amplitude is negative, so if you have a negative A value in your equation, then it switches the graph. So the first half is underneath and the second half is above. But we'll go through an example like that. Let's look at the period shift. So the period shift is the B value. You can see that's right in front here. It is multiplying by theta. So because B is in front of a parenthesis, remember that means multiply. So if it's a B value, if it's not there, right? If we don't see it, we know it's a secret one. So similar to the amplitude, it would be a secret one. And it makes the shift, or it makes the period shift makes the cycle of the graph happen in larger or smaller spaces. So that's when we were looking at the Desmos thing, we saw it get wider or smaller. It was lots of little peaks or it was fewer wider peaks. So that's what that controls. This is an important formula to make note of. If you want to know what the formula, or if you want to know what the period is going to be, you have to use this, where you would plug in your B value here, and you would do 2 pi divided by whatever your B value is. So let's say it was 2. That means your period would be pi. So you'd have a shorter period, which means you'd have lots more little peaks in your graph. All right, let's look at the last way we can change a periodic function, a sine graph. We can neutral value of 0. That means this h value here, notice it's inside of the parentheses with the theta. And also notice, just like in quadratics, it says minus h, and it's going to be doing the opposite thing as what you think. So if it's a minus, then you go to the positive side. If it's to a positive, then you'd go to the negative side. It moves the graph left or right. And what you want to do when you're graphing is mark the first point on the y equals k line. So that's the first thing that we looked at, the k value. Every key point in the graph is shifted left or right by that same value. So that one I think is the trickiest one to deal with, in my opinion. So we'll go through some examples together. Oh, I wanted to mention, I'm going to be checking all my answers using that Desmos website that I linked at the beginning of the lesson. And you can always use this. It's always going to be here. You just go in and you can change the different values. So if I wanted to know, and I'll make sure these are at our neutral values. Oh, something that's kind of useful is that you can press refresh on this graph and it'll take you back to all the neutral values of all your possible ways you could transform sine, can change your sine graph. So let's say I wanted to change k to a 6, right? Well, I can just type it in rather than having to deal with the little slider. And then it's higher up, it's at 6, right? Right here, it's at 6. That moves our y equals k line up. Okay, so now that we kind of understand that, let's reset this graph. Let's go back and let's try and figure out how to do this on our own. So I'm going to be switching colors here a lot just to make sure that we understand it. what I'd like you to do as a strategy, at least at first, is to write down all your values. So start and do them in this order that I have these different values listed, because it's going to make it the easiest for you to figure out. So you look at your K value, it's +2. You look at your amplitude, there's no amplitude shown, right? There's no A value shown. You know that means there's a 1 there. There's a secret 1 in front of the sign being multiplied. All right, and then our B value, there's no number multiplying the theta symbol. Well, you know that it's a secret 1, right? Just like how if you had an X, it's actually 1X. So our B value is 1. And then we have our H, which is our phase shift, and nothing is being added or subtracted from the theta. And so that means we have a 0, because adding 0 is the same as doing nothing. So the neutral value for H is 0. All right, so let's take a look here. Remember the K value in green, that's the center of our graph. And so instead of having to go up and say, okay, here's 2 right here and draw a line there, and then having to like redo the sine graph, what I want to do is just relabel the points. So my middle point is going to be 2. It's no longer the x-axis, the theta axis at 0. It's now shifted up to 2. So that's our center point, our vertical shift. All right, so now A is 1. Now, a lot of people get a little confused on this. Remember, A is yellow, Francis. Okay, so the amplitude is the amount it goes up and down from that center line. So since we're at 2 in the middle, 1 more than 2 would be 3. And I like to kind of make a little path for my graph just because it can make it a little more symmetrical and a little prettier, to be honest. And then if we go down from 2, we would be at 1. And draw my little thing. It's not exactly the same, right? That's okay. It doesn't need to be a masterpiece. All right, and then we have an H value of 0, and that means nothing has changed, so we don't need to worry about that. So that's, or in a B value of 1, so that means our period is going to be, we could look over here and use the formula. We can say if our B value is 1, it's going to be 2 pi over 1, which is just 2 pi. So it's like a normal circle. We don't have to make any changes there. And then, the H value is 0, so that means we don't have to make any changes there. So let's practice our skills. We know that at 0 radians, we start at 0. At 2 pi radians, we end at 0. We know that the symmetry of these key points means that halfway around the circle, we're also at 0. We go up first because sine goes up to 1 on the unit circle, and then we go down when we're at 3 pi over 2, and then we just draw a picture of the graph as best as we can. So what I want you to do in order to get full credit for these graphs is I want you to mark the points. So this first point is at 0, 2. The angle is 0. The y value is 2. Here we have a angle of pi over 2. And our y value is 3. Our sine value is 3. Since we're multiplying everything by 2, it would have been, or we're adding 2 to everything, it would have been at 1, but we're adding 2 to it, so it shifts it up. Here we are at, not 0, we are at pi 2. So the input is the angle, the output is the sine value in the function. And I'll show you a little something you can do with this too. Here we have our 3 pi over 2, so we're 3/4 of the way around the circle. And then we are down here. It would have been -1, but we changed it. So we added 2 to that, and now we're at +1. And then this final point is 2 pi, and we are back at 2, not 0. Because that's the same height as the original point we started at. So let's take a look at how I could possibly check my answer. I know that I have sine, and then my function is sine theta plus 2. So I could do sine, And let's just try pi over 2, right? So I could do pi over 2 and then plus 2, just like an input into a function, and then you're getting your output, which is 3. And so that shows me that this answer that I got here, this point, this key point that I labeled, is correct. Let's try checking our answer one more time. So what if I tried this one here where we're at pi now, right? Instead of pi over 2. So sine of pi is my angle, it's my input, plus 2 is the thing that we have in our function now, and our output is 2. So input pi, output 2. I did it right. Here's another way you can check your answer. You can go to the Desmos thing that I created, and I know that everything was neutral except for the K got changed to a 2. So I'm going to tap in here with the K, and I'm going to go, you are no longer neutral, you are now 2. And then here is my new picture. And I can tap on all of these key points, and they should be the same as the key points that I was able to get. Okay, so I'm going to go through 3 more examples, and I'm going to show an example of what every different change, all of the 4 different changes you can have, do specifically to the graph. Again, if you don't need this, you want to try it on your own, then please feel free to skip ahead. But if you do need this, come along for the ride. Okay. So let's go back and start on teacher question B. So teacher question B, we're going to write down all our values. We have K. There's no K shown, so we would say plus 0 equals 0. Our A value comes next. I see that there's a 4 in front of the sign, so that means 4 is being multiplied, so our A value is 4. And then my B value, sorry, my phone went off. My B value is going to be 1 because there's nothing multiplying the theta. And so if there's nothing multiplying the theta, then your B value is just 1 because it's a secret multiplication of 1. And then our H value is going to be 0 because there's nothing inside of the parentheses being added or subtracted from the theta. All right, so let's do it to it. We have K is equal to 0. So that means that we're not changing this. This is just our x-axis or our theta axis. It's just at 0 like we would normally see it. Our A is now 4. Okay, so what that means is up from that K line and down from that K line, I'm going up 4 and down 4. So up from 0, 4 is just 4. So I put 4 here. And then down from 4, or from 0 is negative 4. So I put that there. And then I'm going to draw this. I'm overlapping with the other question, but that's okay. Just giving me like something that's a little easier to do the symmetry of the graph with if I put those lines there. You don't have to, but I think it helps me a lot. All right, and then our B value is 1. Again, what that means is the B value has not changed. We could show that by doing 2 pi over 1, which means that our cycle is still just 2 pi units long. And then again, our H value is 0, which means we're not going left or right. We'll see that in a couple questions here. All right, so let's do our key points. The key points are all exactly the same. You just have starting at 0, ending at 0. In the middle, you're at 0. At pi over 2, you're at your maximum. At 3 pi over 2, you're at your minimum. And then we just use kind of our muscle memory to draw a nice picture like that. Something that I see a lot of students do when they're first learning how to draw a sine graph is they'll make a point. They'll do like a point like that. That is incorrect, and you'll be marked incorrect if you do that. So just keep that in mind. You got to make sure you're not doing hard peaks. You want to make sure you're doing rounded peaks as you go through. Okay, so next one, we are going to do starting over, listing all of our values in order. We have, again, K is equal to 0. And then for question C, okay, we got A is equal to 1 again. We have b is equal to 2 now. Ooh, we haven't seen that yet. And then we have h is equal to 0. So keep your eyes peeled on this. We got this. We're going to do it. We can do it. Starting at k equals 0. Same as the last one. It means that our middle line is just what we would expect. It's right at 0, no change. And then we have an a value of 1. That's neutral, right? That's like a normal unit circle. So that means we would go up 1 and down 1, just like the sine graph we were making at the beginning of this. And again, you can make your little path so that your graph stays more symmetrical if it helps you. Now we have something a little different. We have a b value of 2. So that means we need to figure out what is our new period going to be. So using our formula, you say 2 pi over 2. That's going to be pi. So what that means is it changes some of our symmetry. It means our whole cycle, our up, middle, down, middle, happens in less time, half as much time. So what we need to do is we need to mark our beginning, which we're still going to start at 0, and we're going to mark our end. And then we're going to have the same exact symmetry, but squished. So in the middle, we still are at 0. And in between that, we still go to 1. And in between that, we still go down to -1. And the requirement is only that we draw one cycle. So we don't have to keep going with this over to 2 pi. The requirement is only one cycle, 5 key points. So here we go. We got our 5 key points. Oh, I just realized I didn't write the 5 key points on the last one. Let's go back and do it. All right, so this would be at 0 radians, 0 height. This would be pi over 2, height of 4. Here we would be at pi, 0 height. Here we would be at 3 pi over 2, down at -4. And then again here we would be at 2 pi, and then that would be at 0. So we can double check our answer a couple different ways. We can use our calculator, or we can use our Desmos checker. It's up to you. I like to use this because I just created it. It's kind of sparkly and new for me. So on that one, our a value was 4. So it changed it. So we have much higher peaks, but I'm going to redo this. And then I can click on all these points and check that I got all my points correct. Okay, back to the action here. Let's do our key points for this. So again, this is 0 radians, 0 height. This would be pi over 4 takes us to our highest height of 1. Our pi over 2 is now our middle, so we're back at the 0. Our 3 pi over 4 takes us down to our darkest depths, which is -1. And then here I'm at pi, which would normally be 2 pi, but it's pi now because we cut our period in half. And we are back at the neutral value of 0. Okay, I'm going to check our answer the other way using the sine, using our calculator here. There we go. Let's use our calculator to check our answer. Our function is, remember, our function is sine 2 theta. And so that's what we're going to use in our calculators. We're going to say sine of 2, and then times our first angle is 0. 0, good, we got that one right. Let's do sine of 2 times pi over 4. Hopefully it's a 1. Cross your fingers. Yeah, we got it. All right, next one. I'm not going to do that. Or yeah, I am. So this is, now we're going to change this to pi over 2 instead of pi over 4. That's our next value. Got it, crushed it, doing great. The next one is going to be 3 pi over 4. So let's go back into our function. 3 pi divided by 4 now. And we got -1. All right, we're doing great. Last question that we need to make sure we got right. This is going to be pi here, and it's 0. So we did great. Let's keep going here. Last one for me, and then I'm going to pause and you got to try on your own with some different values. Okay. Here we go. We have our final function is example D, where we have an H value. This one is tricky. I'm just giving you a little bit of warning. This can be a little tricky. So let's go through and write down all our values in order. K is still 0. A is 1. B is back to being 1 now. We don't have anything multiplying. But our H value is pi over 4. Okay, so keep in mind, it's not negative pi over 4, it's pi over 4. This is part of the general formula. So remember, it's always the opposite sign than you think it's going to be. Your H is positive when you see a negative, and it'll be negative when you see a positive here. Okay, so let's go through and do it. We have our K is 0. That means that our neutral K value, so it's just we have a line in the middle. Symmetry is surrounding 0. Our second value is A equals 1. The amplitude is 1. And so that means our highest height is going to be 1, and our lowest low is going to be 1. That's our maximums and our minimums. Our peaks, right? Our waves are going to go as high as 1 and as low as 1. And then our B value is 1. So if we wanted to, we could come over here and say, okay, that means our B value is 2 pi. So let's mark that real quick before we do our H value. So it's important that you mark the start and the end when you know your B value, and then go on and do your H value. It's really important that you do it in this order, and you'll see why. So our H value is blue. So H value is pi over 4. What that does is it takes the angle and it moves it to the right 4 or pi over 4. So instead of starting at 0, you are going to move over to the right pi over 4. You're going to move over to the right pi over 4. Well, what does that mean to the rest of the points? It means exactly the same thing happens. So we used to have our middle in at pi, and now because our H value is pi over 4, we move it over pi over 4. Same thing for our 1. We used to have our maximum here. We're going to move it over 1 pi over 4. This graph is marked for pi over 4s. I will not give you something that is not a pi over 4 or pi over 2, so don't worry about that. So here is where this point used to be, but now I have moved it over, and it is over pi over 4. All right, so what does that mean for our points that we need to graph? It means that we're going to start at 0 here. We're going to go to up to the 1 here, down to our, down to 0 here, down to -1 here, and up to 0 right there. So all the red dots is where it would be normally, and the blue dots is where it is now. And we just connect the dots to make a nice little sign graph. All right, you guys give yours a shot. There's some tricky parts to yours. You know how I like to do something that's really simple and then give you something a little more complicated to make you think. Go ahead, pause the video, and then, oh, I forgot to put the key points. Okay, real quick, I'll do the key points here. So this would be pi over 4 for our radians, and then our output would be 0 because we're at the center point. This would be 3 pi over 2, and we're at +1. This would be 5 pi over 4, and that gives us a sine value of 0. This would be at 7 pi over 4, and that gives us a sine value of -1. And this is 9 pi over 4. We're 1 past 8 pi over 4, right? So then this would be 0. And I'll just check one of them just to make sure that we know how to check this. So our function looks a little different. It's going to be the angle value. So let's try 5 pi over 4. So 5 pi divided by 4. And then we have to be careful because we have to make sure we're doing our parentheses right. If you wanted to use the fraction button, you could. And this is minus pi. Oops, got to make sure we're using parentheses here. Never know how different calculators interpret these different things. And we got 0. So I input 5 pi over 4 into the function, and I got out 0. So I know I did it right. Again, the other way to do it is to go to your Desmos here. Remember, you can always just press refresh and it'll put everything back to a neutral value. And what we were learning about is what if we put in pi over 4 for h. Remember, it seems negative, but it's actually positive. So pi over 4. And then if we tapped on all these values, hopefully we would get all the same answers, which we did. Okay, now you're going to pause and you're going to try those student examples. And then when you come back, I'll have all the answers ready and we can talk through some of the little trickier parts of them. It takes me a second to pause. This is the awkward part. Oh, I can pause. I can do it. Okay, let's check our answers together. We have to reconnect my iPad. Give me 1 second. I'm going to pause it again and get this right. Okay, I think I fixed it. Let's do this. All right, we got here's our graphs that we made, kind of squished together, so I apologize. I'll try to go through them individually. So remember, this graph has a change in this -3 here. So the k value is -3. So pretty much the only thing that changed was that this line here in the middle, the line of symmetry down the middle there, is no longer 0, but it's at -3. And then that means you go up 1 from -3 to get to -2. You go down 1 from -3 to get to -4. That's the only tricky part about this. Everything is exactly the same. All right, our second question, the only thing that has changed is the A value. So that just means the peaks are a little higher and a little lower. This A middle value is still 0. You go up 2 from there and down 2 from there, and then double check all your points. Again, that Desmos website that I created is going to be really helpful. It's going to help you check your answers very accurately. Okay, and then our next one is a little tricky. You haven't seen this before, and I used a little bit of tricks to do it. K value is still the same. We have the same neutral A value, which brings us up 1 and down 1 because the A value is 1. And then the tricky part about this is that we had a B value of 1/2. So when we use the formula, 2 pi divided by 1/2 is the same as 2 pi times 2. And so actually our period got twice as long. And so what I did, I kind of cheated a little bit, was I didn't try to like extend the graph way off of the thing. I guess I should go the other way to extend the graph way off of the page. I just changed the numbers. So under here, this would normally be 2 pi, but since our period is twice as long, I changed the number to 4 pi. I crossed out these values that we don't even really care about, and then I just multiplied all the other values by 2. So that's a strategy you're welcome to use instead of, so that you don't have to like keep writing and like extending it off the iPad basically. Okay, and then this next one is tricky, very tricky. What changed was that, well, we have the same 0 value here. We had the same A value at +1, so and then -1 for our symmetry. And then the crazy thing that's going on here is that the h value was -pi over 2. Even though up in the equation it says plus pi over 2, that's because it's minus a negative pi over 2. And so actually when you see a plus, you know it's a negative. This one means we have to go to the left 2 groups of pi over 4, right? So each one of these chunks is pi over 4. This chunk is pi over 2. And so what I did was I showed it moved over 2 units on our, like we have this marked off, that's like 1 unit kind of. So 2 groups of pi over 4 on my graph. And same for the ending point, I showed that moving 2 over, and then all the other points also moved 2 over. So yeah, use the Desmos to check your answer. Make sure you got that right, or calculator. You can also check your answer. We're gonna move on. Hey, this is a long lesson. You know that sometimes I get going. I do a lot of extra explaining. I do a lot of extra problems. So now would be a really good time if you want. Pause, get a drink of water, walk away, come back tomorrow. Now would be a really good time to do that. You can start by, if you wanted to stop here and do more practice, these are all the level 1 questions on the worksheet. So the worksheet is separated into different levels, just like this is too. I forgot to mention that, but this is level 1 questions. So they're the most simple. There's a level 2, and then there's a level 3 as well. So again, stop here, take a break. If you want to switch over, do the level 1 questions on the worksheet to make sure you're understanding this before you move on. I'm going to keep going now. All right. So notice here that each one of these equations has 2 changes in it. So we're not just going to be looking at one difference. We're going to be looking at 2 differences at the same time, and it can get really tricky. That's why it's important we had that strategy of saying, okay, what's our k value? Well, in this case, k is positive 2. What's our a value? We can see that there's no a value, so it's 1. What is our b value comes next? We got a b value of 2. And then what is our h value? We have an h value of 0 in this case. So k is equal to 2. We know that means we have to change our middle line to be 2. Since our a value of 1, that means we have going up 1 and down 1. And then our b value of 2 means that we have to do 2 pi over 2 to find that our period has been changed to 1 pi instead of 2 pi. It's been cut in half. And so we start here at 0 still, but instead of ending at 2 pi, we end at pi. Well, the symmetry is exactly the same. It's just been squished into a smaller space. So we know we can start and end there. And then our middle is in the middle. Here we're at there. There we're at there. It's halfway points, right? Every time you just cut whatever the period is into 4 equal parts and place your 5 key points, and then you can draw your picture the best you can. And that's it for that one. Let's keep going. Oh, I got to do my key points. Keep forgetting that. So this is going to be pi 0. Oops, nope, because we have an a value of 2. So pi 2. This would be 3 pi over 4 at 1. This would be pi over 2 at 0. This would be pi over 4 at 3, and then at the beginning we started at 0 radians, and the k value is 2, so we start at 2. Let's do another one. We have our strategy. K is equal to 0 in this one. We have a is equal to 4, so that's a change. B is equal to 1. No change in our period. We're still going to have a period of 2 pi. And then our h value is going to be pi over 4. Remember, it looks negative in the equation, but it's actually positive. It's the opposite of what you think. Let's go through it, starting with our k is 0. So remember, that means our middle line we mark as a 0. Our a value is 4, so that means we have to go up 4 and down 4 from there. And again, I didn't do it on the last one, but sometimes it's helpful to draw little guard lines so that you keep your thing straight. Actually, on this, I know I'm just not very careful about it, but you can, how do you do it again? You can long hold, so there we go, and make it a straight line. I'm sure you guys are much better at this kind of stuff than I am, but yep, there we go. I got a long hold, and then it makes it like a nice straight path, and it'll be more symmetrical looking if I have that guide. All right. So that was our a value. Our b value is 1, so that means nothing has changed for our b value. So that means I'm going to mark the start and the end where it should be. And then this is the tricky part. So our h value has changed. It's a positive pi over 4. So that means every single spot is going to be moved over to the right pi over 4. So the beginning moves over pi over 4. The end moves over pi over 4. And so actually it's going to start here and end here. But the symmetry is still the same. So if I were to go halfway between those two, that's where we're at 0. Halfway between those two is where you're at your maximum. Halfway between these other two is when we're at our minimum. So I might have to move my floating head here so you can see it. Okay, so now just connect the dots. We got a beautiful sine graph here. We need to put in our key points. This one is pi over 4 and 0. This one is 3 pi over 4 and 4. This one is 5 pi over 4, 0. Down here at the bottom, 7 pi over 4 is at -4. And then finally, we have 9 pi over 4, comma, let's squeeze it in, 0. All right, so your turn to try some student examples. I'm gonna pause and get after them. I hope you pause and try them on your own as well. See you in a minute. Okay, let's do the checking of our answers for you. You might realize that we've seen all these changes before. I'm just putting them together, so hopefully it wasn't too much of a stretch for you. But let's take a look here. So remember that when you have a b value, move this out of the way. Remember, when you have a b value of 1/2, it means you're dividing by 1/2, which is actually the same as multiplying by 2. So you get a bigger period. You get a stretched out sine graph. And so that's why I changed all these values here in this graph. And you can see if you wanted to go in and check your answers on these, you can. But the only changes were that, you started a different spot at -3 instead of 0. And then your values are twice as far as they would have been in a normal unit circle or in like a parent function of the sine graph. Okay, so let's do this one. This one's probably the trickiest one because you have to move everything over 2 places, but also the amplitude is now 2, and so you go from 0 to 2 instead of 0 to +1. So just to give you guys an idea of how you could check your answer using your graph or your calculator here, remember that you're looking at the original function. The original function is 2, let's look at question B. So 2 times sine, and then whatever angle you want to try to make sure you got it right. Let's try pi, why not? So just put pi in there. And then plus, and then we want to be careful because we're adding pi over 2. That was our h value. And then that would be -2. And so that proves that we got this one right because we had an input of pi and output of -2 when we did it on our calculator. Or maybe you can't see what I just did in my calculator, sorry. There we go. So you can see how I put it in. 2 sine pi is the theta value in the equation. And then this is our h value, pi over 2. And so then we would have a output of -2. And so that's why when we do this, we get pi as our input and -2 as our output. Sorry if you can hear my cat running around, but it must be that time of day where he's being all crazy cat. Okay, so let's go back. And like I said before, if that's good, like you're good at level 2, that's fine. Take a break, pause, go try the worksheets, and make sure you're ready to do level 2 questions. For the formative and the summative, I would expect you to be able to do a couple of level 2s, mostly level 1s, understanding how the graphs change according to the different vocabulary terms, vertical shift, amplitude, period shift, and phase shift. So make sure you got that vocab down. But other than that, yeah, level 3 is going to be like maybe an extra credit question. So if you want to pause and be done, go ahead, pause and be done. But if you're having fun, you want a little bit more of a challenge, let's do these level 3 problems, give them a shot, why not? And we will, I put some of them on the worksheet too, so it's kind of fun. A little extra challenge if you're up for it. Let's take a look at this first. Level 3 question. So I'm just going to use our same strategy. So starting with the K value is 2. Our A value is 4. Our B value is 2. And our H value is pi over 4. What I'm doing here is I'm just taking all the changes we've already seen and putting them all into one equation. So let's go through. We have K is 2. So that means this middle value here is going to be 2. Our A value is 4. Maybe I didn't keep them exactly the same. I meant to. Oh well. So our A value is 4. So that means we went up 4 to 6 and down 4 to -2. And we're going to draw our lines that go out from here to help us have a prettier graph. All right, and then if our B value is 2, remember that means we have to do 2 pi over 2, and that is pi. So we got a smaller graph, cuter sine graph. So we start at 0 still, but we're gonna have our whole sine graph within pi. So there we took care of that. And now we also have to take a look at this pi over 4. So since it's a positive H value, even though it looks negative in the equation, it's positive actually, we know that. All these values move over to the right, one group of pi over 4. So not really too challenging, just putting everything we've thought about all together at once. And so the symmetry is still the same. So halfway between those 2 points, we're at 0. Halfway between those two, we're at 1 at our maximum, down, and then halfway between the other two, we're at our minimum. So we would draw our cutie little shifted graph. And again, we can go here. This is our input is our theta, and our output is our sine value. And here we have pi over 2, output of 6. Here we have 3 pi over 4, output of 2. Here we have pi, output of -2. And then last but not least, we have input of 3, that's, 5 pi over 4, sorry, 5 pi over 4, and then output of 2. So I'll just show you how you can do this on your calculator to check your answer just to make sure. So we're rewriting the function. It's 4 sine 2, and then let's just check our answer for pi over 4, that first point in our cycle. So I'm going to put in parentheses just to be careful, pi over 4. And then we have minus pi over 4. That is our H value. Close those parentheses again because we need to make sure that we are careful about where our parentheses are. You know, to close those parentheses again, see, this is why the fraction button is nice because it kind of looks a little bit more similar to what your equation looks like. And then you go plus 2, and I get an output of 2. Yeah, that checks out. I'm all good to go there. Or you could go in the decimals, put in all the different HA values, all the different 4 values, and see if you get the right points. Okay, go ahead and try the student example on your own. Then we'll come back and I will show you the answer. And this is the awkward part where it takes me forever to press pause. Stick with me. Okay, ready to check it? Your guys's was way harder than mine, by the way. I did not really, it was hard. Okay, so let's take a look. I think yours would be a little bit more than a level 3 actually, and I don't think I would ask you to do this at all on a quiz. Even extra credit, level 3 is meant to be like the highest challenge, so I don't think this one was even beyond that a little bit, I think. So let's take a look here. The big idea that I want to talk about is that Okay, so you got to the part where you had your b value of 1/2 and you marked your 4 pi. So that's these marks in red. But then your h value was negative pi over 2. So that means you had to shift everything over pi over 2. Everything had to be shifted over pi over 2 from where it would normally be. And that was really challenging. I had to break out some fractions, adding and subtracting fractions. So, for example, like I knew that my point used to be at 2 pi right here, but then I had to shift it over pi over 2. And so I did 2 pi minus pi over 2 to get 3 pi over 2. That's why there's this value here. And then another example here would be this 3 pi over 2. I had to shift it to the left, pi over 2. So I had to subtract pi over 2. So then I had to change the denominator so that I could subtract a pi and to get 5 pi over 2. Woof. This is doing a lot, you guys. This one was really challenging. It's okay if you got stuck in the middle and wanted to, tap out on this one. I understand. But also, I hope you're challenging yourself because this is like IB level questions. If you can do these, it means you really understand it and you're using lots of different qualities and skills. So I would recommend it. Again, this is me just like doing fraction addition where you have to subtract pi over 2 from 8 pi over 2. So hopefully you're able to check your answers either using your calculator or Desmos. We haven't looked at the Desmos thing for a while, so let's go refresh that. And let's see if I can split screen with the Desmos. All right. There we go. Oh, wait, no, it wasn't the Desmos app. Oh, okay. You guys are so patient with me watching me try to figure out my technology. I appreciate you. Okay, Chrome. Okay, so here I'm checking my answer and I have to go through and change all these different values here. Not sure why that is changing like that. Okay, so change the k value. We had a k value of -3. Let's change our a value. Our a value was 2. Let's change our h value. It was negative pi over 2. And then our b value was 1/2. Ooh, these are kind of out of order. Okay, so let's try and zoom out on our graph and see if we can find our graph here. Okay, so our middle line is at -3, and our first point is -3, negative pi over 2, -3. Okay, I got it right. And then I would look at my next point, which is pi over 2, -1. Check, check. I'd look at my next point, 3 pi over 2, -3. Looking good. Next point, 5 pi over 2, -5. Remember, amplitude was 2, so we had to go down 2 from -3 to get to -5. And then our final point, 7 pi over 2, comma -3. Hey, I win, I win, I win. All right. Yeah, I know I get a little too excited. I get it. All right, so if you wanted to do something really extra crazy, you could try this challenge problem. You're going to run into all kinds of crazy things on this one, but I encourage you to give it a shot. As usual, I am not going to show you in the video. You have to try it and then go look at the teacher notes so that you can see the answer, just a little more push for you. I'll give you a hint though. You are going to want to completely get rid of all of these markings. You're going to have completely different markings here when you do it. So, tip. All right, good luck this week. I know that seemed like a lot. I would definitely recommend that you do the worksheet because it's going to be this stuff. You need some time and practice to get it to really solidify into your head. Another thing to keep in mind is we're going to be doing this exact same thing next week, but with cosine. So learning this now is going to really help you to do it next week. And also, if it was a really big struggle this week, just know that next week is almost going to be exactly the same. So you're going to have more practice with the same materials. And so maybe you'll understand it a little better by next week. Okay. Keep in mind my office hours are changing this week. Tuesday, I'm not having office hours from 1:30 to 12:30, but I will be having them from or at a different time. So make sure you're checking the schedule and emailing me with any questions. Very happy to help. Good luck.